And the VT100 was 24 lines, and 2 of those lines were used by the editor, so that was about 20 lines of code. But nowadays, we've all got these laptops with really massive monitors, and we can crank the font way the heck down and get 500 lines of code on the screen. And they're all 800 characters wide. We don't want to do that. We want our functions to be small, nicely small. We want lots of little tiny functions. We want good variable names. We want good function names. Clean code starts at the very bottom, the lowest level details, the stuff that we almost ignore nowadays. Clean code begins with a line of code, and then we practice improving those lines and keeping them nice and readable. Test-driven development. The jury is in on this one. There's been loads of controversy since it was first introduced in 1999. The industry kind of went into turmoil. The whole idea of writing tests first was considered nonsense for a while. But the jury really has finally come back on this one. This is a fundamental professional practice. In fact, it is difficult to imagine professional software being written any other way. Who is a TDDer? How many of you are writing code in using TDD? Now let me describe what test-driven development is. And then you can see if your hand still stays up. There are 3 laws of test-driven development. The first law is, you are not allowed to write a line of production code until you have written a failing unit test. You cannot write any production code at all until you have a failing unit test that fails because of the code you have not written. The second law is, you are not allowed to write more of a unit test than is sufficient to fail. You cannot write a whole great big bunch of unit tests without any production code. You must stop writing a unit test as soon as it fails. And not compiling is failing. So you must stop writing the unit test as soon as it does not compile. Now, since you are writing a test about code that you have not written yet, the unit test is very likely to not compile pretty quickly. 1 or 2 lines of code, and then you must stop and start writing production code. And now the third law kicks in. The third law says you are not allowed to write more production code than is sufficient to pass the failing test. This locks you into a cycle that is perhaps 30 seconds long. You're going to write a little bit of a test, and you must stop quickly because you've written some code that references a module that doesn't exist. You will then write a little bit of production code, but you can't write any more than will make that unit test compile. Then you'll write a little bit more test code, a little more production code, a little more test, a little production, always running the tests. This is not really test first. This is test code and production code simultaneously, with the test code leading the production code by maybe 30 seconds. Who does this? Fewer than before. It's interesting. And the rest of you are going, well, that's stupid. How can anybody do that? It's slow, it's tedious. I've got a brain, I can think, I can write code. I'm not questioning whether or not you've got a brain. I assume since you're sitting in this room, you probably do have a brain. And of course, those of us with brains can write big masses of code without any tests. You've probably got some. I'm not asking you about that. I'm asking you to not write that code that way. Write your tests first, then write the code in this little cycle. Because when we do that, there are a tremendous number of benefits. Imagine a group of people, 10 or 12 developers sitting in a room. They are behaving the way I just described. They are practicing test-driven development. Go to any one of them, doesn't matter who, at any time, doesn't matter when, a minute or 2 ago, all their code executed and passed its tests. And it doesn't matter who you pick, and it doesn't matter when you pick them. A minute or 2 ago, all their code executed. Now think about that for a minute. How much debugging would you do if a minute or 2 ago, all your code executed and passed its tests? The answer is not very much. You would not be debugging very much because you had it all executing. The practice of test-driven development forces us to adopt a style of writing that keeps the code executing every couple of minutes. We cannot rip the code to shreds. We cannot tear it apart and hope to get it back together next Tuesday. We've got to keep it If we work this way, we will write hundreds of tests a week, thousands of tests a year, and we will keep all those unit tests in a nice little place where we can run them at the click of a button. What is it that makes software flexible? For decades, we have argued about making software flexible and maintainable. How do we do that? Well, we've talked about architectures and objects and good design, and all those things have an effect. But what we have found out in the last 6 or 7 years is that the effect of architecture and design is a secondary effect. The thing that makes software flexible and maintainable is tests. When you have thousands of tests that you can run in a matter of minutes, you push a button, you see a green light up, and you know that 100% or very close to 100% of that code has been covered, you are fearless about changing. You can reach into that code and start changing it, and of course you're doing that in the same 30-second cycle. Make a little change, run all the tests, it still works. Make a little change, run all the tests, it still works. You can change it. You can clean it. You can add new features to it and know that you have not broken anything. This makes code flexible. Design helps, architecture helps, tests are the first order effect. QA. Who's got a QA group? Okay, and so the development team, they're in a hurry because they've got to get to their deadline, so they're writing code, and then the deadline comes and they take all that code and they throw it over the wall to QA. And what does QA find? It doesn't work. So what do? They ship a whole bunch of bugs back over the wall. Now the developers fix all those bugs and they ship that code over the wall. And the QA people run their tests and they ship all the bugs back over the wall. And the list of bugs gets bigger. Some of us use QA to find our bugs. This is unprofessional. QA should find nothing. That should be your attitude. If you are a serious software developer, if you consider yourself to be professional, then you will have done the due diligence. You will have written the tests. You will have made sure to the best of your ability that QA finds nothing. Now, of course, QA is going to find something because we're not perfect. But our attitude should be QA finds nothing. And when they do find something, we should take that as a hit. That's something that we as professionals did wrong. QA should not be compiling a huge bug list. QA should be taking bugs off the list. You should be striving, you'll never achieve it, but you should be striving to constantly increase your code coverage. Who measures code coverage? Oh, lots of you. Excellent, excellent. And if you're Java people, you're probably using something like RobertCMartin or Emma or Clover or one of those nice tools. And if you're .NET people, sorry about that, you're probably using NCover or one of those tools. Fine, fine. What should your code coverage be? And the answer to that is it should be as close to 100% as you can get it. Now, most of these tools can't get to 100%. For example, Clover does not count interfaces. It looks at interfaces and it counts them in the line count, but not in the covered count. So if you've got lots of interfaces, your coverage number is just going to be lower than 100%. I have a product at the moment of 45,000 lines of Java code. I've got unit tests all the way through it. Virtually every executable line is covered, but the number it produces is about 90%, which I consider to be pretty good. Managers should not use this number. No manager should lay down a dictum saying our code coverage must meet 90%. This is silliness. Professionals use the number. Developers use the number to measure what they are doing. To have some knowledge, but we don't need a management limit on that. Professionalism is what constrains us to do well, not management. Avoid debugging. Ooh, what a good idea. Avoid debugging. Actually, if you are following test-driven development, if you are following these other practices, you will do very little debugging, but I even want you to avoid that. There is a temptation amongst developers to leap into the debugger. Oh, something's gone wrong. Fire up the debugger.